This time we will be modding flashlights using epoxy. 100 crystals, smart components, and in the end a fully functional prototype made just for fun. Enjoy watching. Hee, what else could we make that involves epoxy, a car, and something new? San, yeah, let's push the car. Okay. Headlights. Car? Let's pour epoxy on the headlights. San, you only have epoxy on your mind. You need to get married. What? Headlights. Why don't you make an epoxy engine too? In the end, the dismantled headlights look like this. They are two-piece, meaning each side consists of two halves, one of which is located in the trunk lid and the other directly in the fender. Jumping ahead, I'll say that this significantly complicated things for us. The main left parts of the headlights, which are glued with sealant, Andre places in a special cabinet where the part can be thoroughly heated. It's all simple there. 3 infrared lamps, which are often used to warm chicks. We leave it for 30 minutes and wait for the sealant to heat up to 70-80 degrees. Unlike the first main part of the headlight, which is now being heated in the cabinet, the second smaller part by the Japanese engineers. For some reason, they decided to glue it permanently. I don't know what they were thinking, but in any unclear situation, we take a grinder in hand, in our case, a small grinder, and split the headlights. Although, to get ahead of myself, I'll say that this was unnecessary and we redid everything a couple of times. That's how it usually happens, since most of our projects are done for the first time and as a single instance. In the process, we often change the concept and add something, so the footage doesn't always correspond to logic and common sense. That's the nature of the work. After the shell in the form of a diffuser is cut off, we move on. By that time, the headlights have heated to the necessary temperature and we can work on them. First of all, we unclip the fasteners. Fortunately, the plastic is heated, making it flexible and pliable. Then we quickly pull it off the diffuser before the sealant sets again. As a result, we have 4 split housings. The next step is to obtain the contour of the upper trim, since the shape and dimensions of the headlights are originally precisely fitted to the car body. And in order not to define the outer contour and edge thickness, we simply cut out the frames. The frame will later be glued to the headlight. This is done using a Dremel tool, and I must say, indeed, this work is not particularly pleasant because unfortunately the plastic heats up and clumps together, and these hot clumps fly in all directions, including towards the face. For me, this was not news, but for San, it was quite unexpected. But I couldn't handle it personally, as I had more important matters to attend to. The safe is not yet assembled, but the frames are almost ready, and they look like this. There's just a little finishing and fitting left to do, but that will be done on site. To accommodate all the necessary components, we remove all partitions in the lanterns using a milling cutter in order to create an open layout later. After we have freed up as much space as possible, in the lanterns we need to create platforms where the crystals and LEDs will be placed. Here we decided not to reinvent the wheel and took the remains of the diffuser, since all we needed from them were the frames that we cut out earlier, and these remnants solve all our issues. Firstly, the plastic is rigid and completely matches the curved shape of the headlight since it was originally a headlight. It's all quite simple here. We fit it to the shape of the lantern, trimming away all the excess along the way. So we have all the necessary components, and we will assemble it using two-component automotive putty. As a result, the reflector plastic is inserted into the light and sealed around the perimeter with putty. Essentially, it is in its standard position as per the factory, just 3 to 4 centimeters lower. This is our concept. The second small lights are made using the same principle, but here we use thin plastic as the surface is flat and working with this material is much easier and faster than with a thick, rigid reflector. The next step is to roughly sand the putty, and before the final application, we attach a pre-cut frame to accurately understand the dimensions. We also attach this frame with putty. First, we place a couple of points and position the former reflector in its original place. As a result, we have a light that exactly matches the factory dimensions. But we'll deal with the filling a little later. Well then, everything follows the old scheme. More putty, a couple of meters of sandpaper, intermediate priming. And after 2 days, we have 4 finished forms. Now they just need to be painted and coated with matte varnish. And now for the most interesting part, making the crystals. For this, we take these reusable silicone molds and mix the resin. It was very important to me that the crystals didn't look like cheap plastic cones. That's exactly why I turned to Olga from Art for Start. And here's why. She makes these molds by taking casts from real natural crystals. So each crystal is an exact replica of a natural stone. Accordingly, they are all different and unique. I'll leave her Instagram in the description. If you're interested in this whole topic, you definitely need to check it out. A huge amount of cool, mesmerizing content. I highly recommend it. In the end, we made several samples in different colors and realized that they would look most impressive. Transparent crystals, slightly tinted with blue dye. All other options looked more like plastic and didn't look as presentable. So, we have 2 out of 3 components. The headlight housings that we made earlier. The crystals, they will serve as diffusers. Now we just need to illuminate them. For this, we ordered an addressable RGB strip with the densest LED arrangement possible. As per our good tradition, we get all our electronics from G4. It's a store. You will find links to all the components in the video description. After the strip is cut into strips of the required length, we solder it. As a result, for each headlight, we prepared this kind of plate made of 8 strips. We drill a hole in the housing through which we pull the wires. The next step is to glue the strips one by one. It's not particularly important for the strip to be laid out perfectly straight, since the crystals that will be placed on top will still lie in a maximally chaotic manner, but more on that a bit later. All the electronics and programming were handled by Lesha, and now a few words on how it works.
The headlight illumination will be controlled by an addressable RGB strip WS282B. We used 144 LEDs per meter to achieve maximum brightness. The lighting of the strip will be controlled by an Arduino Nano. This is a microcontroller, or essentially a small computer with its own memory and processor. We write the program in Arduino IDE using the standard library for this addressable strip from Fruity NeoPixel. The program is quite simple. I think there are many examples of controlling this strip, but to ensure that everything will work, we test the program's operation, efficiency and performance in the Proteus emulator. Here, the circuit is assembled and fully tested. Algorithm of the program. We launch it, and immediately we have almost full functionality. Dimensions, more precisely the brake light, reverse light, turn signal. How do we test the full functionality of the program?
Finally, we have all three puzzle pieces to connect, and we will do it using epoxy. In our case, the compound called Art Eco from Eco Baths, from which we actually cast these crystals. We mix a little resin and pour it into the lamp housing. This layer will act as a conductor, and this is important because later we will fill the gap between the crystals with a black compound. With these lamps, everything is simple and clear because the shape is even. But with the main curved lamps, everything is significantly more complicated. Here we tried to use thicker resin and some other shamanistic techniques. After all the crystals are placed in their positions and the resin has set, we mix the casting plastic. We tint it with black dye and fill all the gaps between the crystals. As a result, most of the tape and wiring is concealed and the picture becomes more appealing. Here is a clear example of before and after the black plastic. Many people probably have questions about the practicality and adequacy of this endeavor. Yes, at this stage and in this execution, it is a technology with limited suitability for everyday use. This is merely a prototype that we simply wanted to create. Such prototypes are made to understand how it will look. Ideally, in the future, a practical working model can be developed from this. Take a mold of the crystal composition and cast it as a whole piece later. And make the base matte, so that the LEDs are not visible through the crystals. Also, create a sensible LED module with passive cooling, which can be replaced if necessary. And of course, install protective glass to cover the crystals, keeping them clean and tidy. All of this is not difficult and can be done after this prototype is tested. And if we like the result, such mods are referred to as modding. This is our first try. If you are interested in this topic, we have a bunch of ideas in this direction. We've already made a table river, then door rivers, so how about headlight rivers? In general, if this direction interests you and the video gets good views, we will do another modding very soon. Well, the best way to help spread this video is to share it anywhere. Also, a long comment, a like and a subscription will greatly help with promotion. Thanks, and may your axe be sharp.